Today we are looking at Fourier sine series and the special property called orthogonality that makes them work. Here is the first key fact, in words first. When you multiply two different sine terms together and integrate that product over the whole domain, the result is always 0. Written out for n not equal to m, integral from 0 to L of sine of n pi x over L times sine of m pi x over L dx equals 0. Here is the second key fact, in words first. When you multiply one sine term by itself and integrate the square over the domain, the result is L divided by 2. Written out, integral from 0 to L of sine of n pi x over L squared dx equals L over 2. Because of these two facts together, we can write any function f of x on this domain as an infinite sum of sin terms. In words, f of x equals the sum over all n from 1 to infinity of b sub n times sine of n pi x over L. To find one particular coefficient, we multiply both sides by a single sine term, say sine of m pi x over L, and integrate both sides over the domain. On the right-hand side, orthogonality makes every single term in the infinite sum vanish, except the one term where n equals m. That one surviving term leaves us with integral from 0 to L of f of x times sine of m pi x over L dx equals b sub m times L over 2. Rearranging this for the coefficient and renaming m back to n gives the coefficient formula. In words, b sub n equals 2 over L times the integral from 0 to L of f of x times sine of n pi x over L dx. Now let us check this by confirming the orthogonality fact we relied on. Take not equal to m and use the product to some identity, which turns the product of two sines into a difference of two cosines. In words, sine of n pi x over L times sine of n pi x over L equals 1/2 times the quantity cosine of the quantity n minus m times pi x over L minus cosine of the quantity n plus m times pi x over L. When you integrate each cosine term over the full domain from 0 to L, each one evaluates to 0 since n minus m and n plus m are both non-zero whole numbers. This confirms the integral of two different sine terms truly does evaluate to 0, so our coefficient formula for b sub n is correct.